Okay, today we're going to be looking at setting up a 1D motion basic equation. Like, what's our first steps whenever we do a 1D motion problem? We'll even do an example of one. So the first thing we need to be able to do is just identify it. And so the first things we need to do for this method is we need to make sure that we're doing one dimension and we have a constant acceleration. If those two things are checked off, what we're going to do is we're going to list our variables. We're just going to make our list every time the same so it's consistent. We're also going to list out our equations. Now the reason we have so many equations is we derive some of these from other equations, like the average velocity equation or the average acceleration equation. Now the reason we use these instead of just average acceleration and average velocity is these have kind of a little trick to them. So for instance, you got to look and see what is missing from each one. So this first one, there's no x value. So what that means for me is if I am doing a problem and there's no x's in it, and I'm not trying to find the position or the displacement, I'm going to want to use this equation. Okay? Or this next one has no v value, no v final. This one has no time. This one has no acceleration, okay? But you will notice that they all have v naught in them. So other than this part of this average velocity equation, so v naught is typically, if you have v naught, you're good to go. If you're not, that might be one of the first things you have to solve. All right, so once we kind of have this set up, oops, missed an O there, no A. We can do a problem. So let's give one a try. So what is the minimum acceleration in meters per second squared and g's for a plane starting at rest and reaching a takeoff speed of 80 meters per second, about 180 miles an hour, on a 2,000 meter runway? So what's the minimum acceleration needed? All right, so the first thing I want to do is list my variables. Okay, so let's think about this. This 2,000 meter runway, or takeoff speed of 80 meters per second. Starting at rest, and then minimum acceleration. So how do I put this stuff into my list of variables? So I know that I'm starting at rest, so that tells me my initial velocity is 0 meters per second, and I want to end at 80 meters per second. So that would be my final velocity. Now the runway is 2,000 meters long, so what I'm going to do is I'm going to say I start at 0 meters, and I'm going to end at the end of the runway 2,000 meters. If they don't give you an initial starting position, they don't say it starts at the origin or it starts at x equals 5, you get to make that choice. And so I like to choose my starting point to be 0. The last thing I need to look at is I'm trying to find this minimum acceleration. All right. So I'm set. All of my units are compatible. So I have meters, seconds, meters per second squared, those types of things, or seconds. If that's good, now I get to pick an equation. So I'm looking for acceleration. I wasn't given time, and I'm not trying to find time. So what that means is I pick an equation without time. Now equation 3 has a little bit of a trick to it if you use it to find v naught or v. Notice these are squared. So when you solve for it, you're going to take the square root, and don't forget when you take a square root, you got to put that plus or minus in front and determine is it moving in the positive or the negative direction. That's on you. All right, but in this case, we are solving for a, so we don't have to worry about that square root plus or minus thing. But let's go ahead and solve for a, and then we'll plug our numbers in. So the first step is v squared equals v naught squared plus 2a x minus x naught. The first thing I'll do is I'll cross out any of my terms that are 0. So that one's 0 and this one's 0. And then I can start solving for a. So right now I have v squared equals 2ax. So I got to get a by itself, so I'm going to divide the 2 and the x over. So I have v squared divided by 2x equals a. At this point, I can plug in the numbers I have. So I have 80 squared divided by 2 times 2,000 will give me my acceleration. My acceleration comes out to be 1.6 meters per second squared as an acceleration. And so that would be the minimum acceleration required. It did also ask me to give it in g's. So this is just basically a different unit. How many times the acceleration of gravity here at the surface of Earth would that be? And so how you convert that is you start with your 1.6 meters per second squared, And you want to get rid of meters per second squared and go to Gs. Okay. 1 G, or 1 acceleration of gravity here on the surface of the Earth, is 9.8 meters per second squared. So basically I'm taking this number, dividing by 9.8 to get it into Gs. And so we find that it's 0.16 meters per, 0.16 Gs is the acceleration. There you go.